Okay, hello everyone. So let's move into the worksheet number 2 from lecture number 2. So lecture number 2, we are mostly talking about electric field. So lecture number 1, we discuss about the Coulomb's law, that is about the electric force. And we know that electric force in magnitude will be equal to K times charge of one particle and charge of the second particle, and divide by distance squared in between two charges. If I have Q1 here, if I have Q2 here, and distance between these two is R. So now direction of this force is depend on what the sign of the charges, right? Because we need to draw the free body diagram wherever your point of interest is, and then we're going to get the direction by using your directional informations finally. And but after we discuss the force, we're going to move into the electric field, because electric field is something that you and that charges can feel because of the around or surrounding particles, right? So electric field, we use the letter E, it is also a vector, will be defined by using force per unit charge. That means newtons over coulomb. But idea is, you can write the force on the by using the top formula. Then you will be able to define, you can rewrite this electric field by using K times one of the charge divided by the R square, right? Because the charge that I have it on numerator is the source charge, which create the electric field, source charge. What is cancelling out is the test charge. What that means? What that means is, simple example, you can say, okay, you have Q1 in here, but because of this charge, if I'm looking for somewhere here which has test charge will cancel out. That's where that we are looking for. So now, if this Q1 will create an electric force, if it is a positive and positive, they're going to repel each other, negative and positive, they're going to attract each other, right? But if you take the test charge, if I have the Q1, then this test charge will feel that I am going to absorb into here or I am going to repel into here. That feeling, we call it as the electric field, right? That's the feeling that particle going to feel. But how that feeling coming up with your charge of the source charge. So the source charge, right? It is depend on the source charge and independent of the test charge. That's why if I have an electric field here, this electric field will be equal to Coulomb constant time the Q1 over the distance in between your point of interest to the charge particle and squared, right? So now direction, again, we need to get from the vector informations. So you know that if it is a positive charge, this will create the electric field outward direction. If this is a positive charge, if it is a negative charge, test particle going to be absorbed into the negative charge. So that will be inward direction towards the negative charge. So we discussed this on the theory, but this is basic idea about that, right? So now, if you have many source charges, again, we have to use the superposition principle and keep adding vectors by using directional informations and magnetic. So that will be the theory part of this. And also, it's very important that you know that the electric field will be created in two opposite direction depend on the charge of the Q, because it is not always the force direction, because you know that electric field is force over Q, right? So now if Q is negative, then you can have the electric field opposite direction from the force. But if Q is positive, electric force and electric field going to be positive, right? Same direction. So let's I think I discussed that also. If Q is positive, E and F are in same direction, right? If Q is negative, E and F are in opposite direction. That's what it means. Okay. So now you can think in here, I have positive, and if I have positive in here, so now my lowercase q here, that is positive, right? So electric force also, they're going to repel each other. Electric field is this way, and electric force also in the same direction, right? But if I have negative in there, so I'm going to erase it and draw it for the negative. If I have negative in here, so if I have negative charge in here, what will happen is, we'll say this one is negative. If this is a negative charge, now what will happen is your positive and negative going to attract each other, but you see that your force will be in this direction, electric force, but electric field going to be direction of this, because it is created by this particle. This is the only effect to your electric field. So now in that case, it is opposite direction. That's what it means. Okay, I think that's enough for the summary. Let's move into the question one by one. So I have few questions for today. And so first question is, there is 2 positive point charges, Q1 and Q2, are separated in vacuum by 3 meters. Find the spot on the line between the charges where the net electric field is 0. You guys remember that we exactly done this question for the net electric force, definitely different values and different distance, but we have done the same problem for the electric force. Now we're going to do for the electric field, right? So now let's draw the cartoon first. I have Q1. Say this is Q1. I know it is positive given. And there is a Q2 that also positive, Q2. And now they are separated by distance 3 meters. The distance between these two, center to center. And now the question is saying you need to keep a charge particle in this setup, but the spot that I'm going to keep the charge particle should be make the electric field 0 on that charge, right? So now, similar to our chapter, the lecture 1, you're going to think that where you're going to keep your spot on your problem, right? As a simple example, you even don't want the information about the test charge. Test charge is the one that you're going to keep in the spot, test charge. We don't want the test charge information because your electric field is defined by the source charges. Source charges are Q1 and Q2 in here, right? So now you need to think, you can do it yourself. I know it is in between, but we'll say I don't know it. I'm going to probably keep my spot in somewhere here. And then check that, can you have electric field left and right to make it 0 in this place? So let's see. So positive charge will create electric field this way. And this positive charge also create the electric field this way, is smaller. Now this all electric fields are to the right direction, then this particle cannot stay in there because there is a field to the right direction. And do the same for the other one. Let's think here, right? And positive charge will create the electric field this way, and this is also positive. That also create the electric field same direction, but it's smaller in weaker than the other one. So now again, that spot going to move into the left direction. Then you decide, okay, that left and right not working, then definitely it should be in between, right? So now you're going to keep somewhere in this line. We'll say I'm going to keep somewhere here my spot, right? So now by drawing the free body diagram on that spot, you can see this positive charge will create the electric field this way, because positive charge always create electric field in outward direction. This is I'm going to label as E2, and whatever I have it on the left side, this particle also positive charge, that will create the electric field outward direction. So that will be this way, right? So now it says that in x direction, your electric field should be 0. Let's label your coordinate system as always x direction and y direction. So in x direction, net electric field should be equal to 0 to make it to stable, right? So now what we know is electric field E1 is in positive direction, E2 is in negative direction, should be equal to 0. What that means is E1 equal E2, right? So now let's try T1 and E2. We don't know this distance yet. Distance is the one that we need to find it out. So let's label the distance from this charge to your spot that you select as electric field 0 as x. And as soon as you know that, this distance will be 3 minus x, right? So now let's write E1 and E2 in under here. E1 equal Coulomb constant. E1 is from the Q1. Q1 is the source charge. Divide by the distance between your spot and the Q1 is x and power 2. And do the E2. E2 is Coulomb constant. Q2 and distance between spot and the Q2 is 3 minus x power 2. So now we're going to go here and write those. Don't plug the values yet, because some of the things will be cancelled out at the end. X squared equal kq2 and 3 minus x squared. So divide by k both side, will cancel out. And then I'm going to write cross multiply and write x squared over 3 minus x squared will be equal to Q1 over Q2, and Q1 over Q2 microcoulomb. I don't want the conversion since I have numerator and denominator, both charges that will cancel out. Unit will cancel out in there. That means Q1 is 16 and Q2 is 4, and that will be equal to 4, right? So now we're going to keep continue, and you're going to keep continue. I'm going to write the answer at the end. And then you finally get x over 3 minus x and power 2 should be equal to 4. Take the root on both sides. That means 2 equal x divided by 3 minus x and find x. Okay. Find x. So I get around 2.0 meters. Okay. So now let's move to the second question. Second question is understanding your electric field formula, because electric field is proportional to the source charge. It's very important. This is source charge, and electric field is proportional to the 1 over r square. What that means is charge increase in electric field increasing, distance increase in electric field getting weaker and weaker. That's the idea. Okay, let's do the part A. If r is double, then electric field. When the r is double, electric field E1 is going to be Coulomb constant k over 2r power 2. That means E1 is 1/4 of E. decrease in how much? 1/4. Okay, next one. If Q1 is double, so that means your source charge you're going to double. When you double the source charge, you're going to write E2 equal twice of KQ over R squared. So that means your E2 will be 2 times of E. That means when you double your source charge, you're going to double the electric field. So now part C, if Q1 and Q2 both are double and R is half, then your E is. So now you're going to double the both charges. That means I have K, 2Q, Q1 and Q2 are double. So you know that the other charge does not affect anything. So 2Q, and you're going to divide by the distance, but R is half now, R over 2 and power 2. So now what will happen to this one? So this one, you see that you can write 2KQ divide by R squared and 4, then 4 go to the numerator. That means your new E3 will be equal to 8 times original. Okay. So that's how electric field calculated or behave according to the charge and the distance. Okay, but this lecture number 2 is mostly same as lecture number 1, but we are working with electric field and questions also almost the same. Okay, but the conceptually we are learning electric field, not electric force. Okay, and so now let's move into the next one. Same question we had earlier. There are 3 particles, two are proton and 1 is electron. So now what is the direction of the electric field due to electron on the central proton? So we need to work with this electron, but this is where my point of interest is. So now point of interest is, we don't care what the charge of the point of interest is, the electric field direction coming from the source charge. So now your source charge is electron. So now electron will create an electric field towards the charge. That will be the electric field from the electron on the left side. So to the left. It did not ask any magnitude or anything, just asking the direction. And then it's asking what the proton do on the right side to the proton in the middle. So now proton is a positive particle. Positive particle will create the electric field outward direction, right? This will create the electric field outward direction. I can draw it on the same place in here, outward direction. So now this is also left on the diagram. What is the direction of the net electric field due to electron and the other proton on the central proton? So central proton is the point of interest to the left. Okay. You remember that electric force also we did the same thing, and also electric force, net force on the middle one was to the left. You go back and check your worksheet number 1. Okay, this problem also we have done by using the electric force. Here we want to do by using the electric field, and I want to rank the situation according to the magnitude of the net electric field now on the center particle. Okay, so now let's move into the number 1 and then do the last one, and then we can you can do the rest yourself. A, B, C, and D. Okay, so now top 1. So let's start with the top 1. This is your point of interest, right? I don't care about the positive or negative because electric field is only depend on the surrounding particles. So now I have negative charge in here, right? Let's start with this one first. Negative charge, electron. So negative charge will create the electric field inward direction. You can keep remind that electric field is depend on the source charge and the distance squared in between two charge, to your point of interest and the other charge. Okay, so now as we know that this is R, this is R, this is R, this is R, all are same distance separated. right? So now we're going to draw the arrows to represent the magnitude and also the direction. So now I have negative charge in here. Negative charge will create the electric field towards the negative charge, but at this point, electric field for this point will be towards the negative charge. That means it's something like this. I'm going to make it a little longer arrow because I know that other one may be smaller. So that will be the from your negative charge closer negative charge on the left. And then we're going to move into this one. That also negative, but electric field is now weaker because R is now double. Other than that, nothing changed. So now you also have electric field this way from that, right? And now we're going to move into the right side. So right side, I have proton in here. So it's a positive charge. Positive charge will create the electric field outward direction from the positive charge. That means in that point, it is exactly same size arrow as blue to the left, right? And then one last one I have is this charge. There is a negative charge, electric field create towards the negative charge. That means in this point, it will be same size arrow as the purple. Then these two going to cancel out. And finally, I have a force electric field in this direction for the top, my A, right? And then you're going to do it for the B and C, and we'll see what will happen on the D. D, you know that you have the this positive charge. If I do, I'm going to use new colors. And positive charge that will create the electric field outward direction. Then this one has the electric field outward direction like this, right? And then I have this charge particle here is a negative electric field inward, but that is smaller, right? And then I have this particle here, electric field is stronger, but it is a positive charge that will create the electric field exactly same size as red arrow, but opposite direction. And the last particle I have is this one, negative charge will create electric field inward. Because of that, in that point, you have this small electric field. So now this and this cancel out, then you definitely have 0 electric field on the D. Okay. So now you're going to do the same thing for B and C. If you have any questions, let me know. I know that this one is the greatest and this one will be smaller than that. Then your order will be C is greatest, next will be A, next will be B, and next will be D. Okay, so now let's move into the number 6. So number 6 asking you to calculate the total electric field at point A or B. You're going to choose. If I do A, you're going to do B, or maybe you're going to do B on your homework. Okay. So let's select the A is the hard and B is easy. So I'm going to select A. And due to the both Q1 and Q2. So this is where my point of interest is, right? So now, as soon as you label point of interest, you should draw the free-body diagram at that place. That is my next question. Okay. So now drawing the free-body diagram, we are doing electric field, not the forces. So now I have positive charge here. Positive charge is Q2 that will create electric field outward from the positive charge. I'm going to label it as E2. And then Q1 I have here. Q1 is a negative charge that will create the electric field towards the negative charge, that is E1. Okay, so now I have E1 and E2. So now what we're going to do, we need to draw the coordinate system because we're going to use the vector information. For that, let's label. You have x-axis in this way and y-axis in this way, x and y, right? And so now we will be able to write E1 and E2. Let's do that first. E1 is equal Coulomb constant Q1 divide by distance. You see that from here to here distance 60 centimeters, 0.60 meters and power 2. Okay. I will just calculate this one because since we have all the information, we be able to calculate. K is 8.99 10 to the power 9 and Q1 is given in here 50. Don't plug the negative in there. 50 times 10 to the negative 6 coulomb and divide by 0.60 and power 2. This will give me 1.25 times 10 to the power 6 Newton over Coulomb. Then E2 also will be able to calculate K times Q2 divided by now distance from here to here is 30. So 0.30 power 2 and plug it and you're going to get the answer around 5.00 times 10 to the 6 Newton over Coulomb. So now I have E1 and E2, but that's not enough for me to calculate the electric field, net electric field. I need to get the information about the direction. That's why I have the free body diagram, right? So now one thing I want to do before moving into anything else, I need the angle that I want to find. I don't know, whichever you label, I'm going to label this is the angle that I need, and that angle will be exactly angle in here, right? Then by side, you're going to write, I can write the tangent of theta. Tangent of theta equal opposite over adjacent. That will be opposite is 13, that angle, and adjacent is 26 plus 26. That will be 52. And then you are ready to write your angle. After that, do I have it? I have 30 degrees. 30 degrees. Okay, I found angle as 30 degrees. Okay, so now we're going to write our information towards X and Y. So we're going to write E. You can write it together or you can do it separately. Let's write the X component from E1. X component from E1 is what? You see that it is fourth quadrant, right? And then your X component will be positive. That will be E1 times cosine of theta, right? And then E1y component, since it is fourth quadrant, that will be a negative. That will be E1 times sine of theta. So we have E1 and the sine theta, then we will be able to calculate this value, right? And I don't have the separate calculations, but I'm going to do E2. Do I have E2x? E2 is pointing towards y direction. Because of that, there is no x component, only y component is there. That is directly E2, right? So now this is we are ready to use the Pythagorean theorem, but before that I need to write net Ex. That will be equal to E1x plus E2x, right? So that will be E1 cosine of theta because E2x is just 0. And Ey will be again y component of both. I'm directly going to write it here. E2 sine of theta plus, so E1 sine of theta, not 2, E1 sine of theta plus E2, right? So now you can calculate if you have values, we can plug it in there. Seems to me, it seems to me I don't have the values separately. I have it. So I have Ex after you calculate, after you plug, E1 times cosine theta. E1 is, you know that E1 is 1.25 10 to the power 6 times cosine of 30, right? Cosine of 30 is root 3 over 2. And I have the value for that 1.0 10 to the power 6. And do the same for E2. Oops. Same for E2, EY. EY equal negative E1 sine theta and plus E2. Okay, so plug E1, E2 and sine of 30 is half. Then you're going to get the EY. What I have is 4.1 times 10 to the power 6 Newton over Coulomb. So now after you know this, you can probably draw your parallelogram. So you have EX smaller and EY is little greater, and complete the parallelogram, right? This is your EX, this is your EY, and then what we are looking for is diagonal one as E, right? And also this as theta. So now you know that E will be in Pythagorean theorem EX squared plus EY squared and square root. You can plug it and then find it out and let me know if my answers are incorrect. I get E equal 4.5 times 10 to the power 6 Newton over Coulomb. As soon as I find the vector, I need to give the direction. So theta will be tangent inverse EY over EX. Again, plug the values and I get the answer as 76 degrees. This is with respect to positive X. Okay, that will be my final answer. Okay. Good. So now we have the last question. Last question is just to see that if you have a parallel plate capacitor, the capacitor has positive and negative terminal, then electric field start from positive terminal to negative terminal, that represent by using these red lines I have, those are electric field, right? So now what we're going to do is we're going to start the electron in this negative terminal. Since electron is not like to stay with the negative charge, electron going to repel each other. Then this electron will accelerate and travel in outside from this hole. That is what happening. The question is asking what will be the speed the particle leave the hole, right? So now let's see what will happen. So we have mass of the electron, very small number, and we have electric field, and the separation is 1.5. That means distance is travel is 1.5 from here to here. And the electron is accelerate from the rest. That information is important. Accelerate from the rest means you have initial velocity is 0, and we need to find the final velocity, right? And then the distance it travel in x direction, that means x final minus x initial, directly given as 1.5 centimeters. Let's change it into meters. So we have 0.015 meters. Okay. And so now electric field is given. Now we need to understand that this will accelerate. This is where it start. This is where we're going to decide as final, right? So now you know that this object has the electric field, right? Because negative particle, you have it in here, that particle will have an electric field, and also it have the electric force. Electric field created by plates, that will be to the left direction. Electric force on Q charge will be to the right direction, right? So because of that, electric force, I will be able to write for this charge particle as charge of the electron and the E. Right. So I'm going to write just magnitude because I know that it is accelerating towards the right direction. So now this will be equal to mass time acceleration of the particle, right? So now I will be able to find the acceleration from this first. Acceleration will be equal to charge of the electron times electric field divided by mass, and this is going to be in right direction or x direction, right? So you will be able to calculate it. 1.602 times 10 to the negative 19 charge of the electron, and the electric field is given 2.0 10 to the power 4, all are in SI unit, and mass is 9.11 times 10 to the negative 31, all are SI units. Acceleration will be able to calculate by plugging those numbers. 3.5 times 10 to the 15. You see, it's a very big number. Meters per squared second. That's the acceleration, but it's not, the acceleration is not the one it is asking about the speed. After you calculate the acceleration, you know that by using those informations, I will be able to calculate the final velocity if I use kinematics. So we know that we learn about the 3 kinematics formulas. We're going to use it for the x direction. According to the given information, I need to choose which formula I am planning to use it. If I remind you the formulas, x final equal x initial plus v initial time plus half acceleration time squared. I am not able to use it, this formula. The reason is I know the axle, but there is no information about the time. So now second equation is V final equal V initial plus acceleration and time. Problem here also time is not given. And third formula, V final squared equal V initial squared plus twice times acceleration times x final minus x initial. That is the best formula because I have all the informations given. So now we can calculate the V final. Let's calculate, plug the values first. Equal, this is 0, and then we have twice acceleration, you already have it. X final minus x initial, we already have it. Okay. So now we need to find the V, take the root on both sides, and then V final. This is my derived formula for this problem, equal x final minus initial, and then you're going to plug the values. Twice of the acceleration you found, and x final minus x initial. Everything is in SI unit. Then you will see the final velocity for the problem. Units of meters per second. What I have is 1.03 times 10 to the power 7. Okay, so that's it for the worksheet number